Alright, so this is a video submission of my A-star pathfinding homework. So as you can see, I have all these A-star nodes in the world, and if you start to drag them around, they try to connect themselves to their adjacent nodes, and it draws a little visual line. And if we jump into the play and editor mode, you can see that all of the lines in the world are connected, and we can see this A-star grid. These are all the nodes connected. Each of these nodes has an internal property, which is the detect range, and it's default set to 500, so it will try to connect to any other nodes which are within 500 units of it. There's another cool little addition here though, and that is I have a test to see if the line would collide. So you can see if I drag this over, as soon as it starts to intersect this cube, the line breaks. And you can see here that ultimately, like, these two nodes should be connected, but the cube is getting in the way of that happening. So these two nodes should currently be connected, but this cube is getting in the way. Kind of cool. That also plays into effect in the real-time A-star pathfinding solving. So by default, the start node is set to be the closest node to the player, and that's this green line, and the end node is way over here. And at any time in the simulation, if we press E, it'll run the A-star pathfinding and give you a little yellow path, and it shows you where the destination is. So come over here, A-star, get over there. But I mentioned that it has real-time collision checking, so you see that that junction there is used by most of these paths that I've chosen. If I push this cube so that it's in the way, now when I try to run the simulation, oh no, it'll collide and then path around. So you can see that it runs down, hits that, and then backtracks around. So that's how A-star pathfinding works. Oh man. The A-star nodes themselves just have like a parent and neighbors. So here's some code that just detects any nodes around this node within range that are not colliding. Here's some code that just returns the neighbors. And then this is the A-star controller here. This is the big chunk of code. This checks to see that there's a destination node and a start node set, and if there is, it will find the closest distant node, and it will sort of expand that node's neighbors, and then all this here has to do with recursion. So it will basically find the closest neighbor, expand it, and then recursively backtrack until it has a valid path to the destination. And it does also include a case for there being no possible way to get to the end. So you can see that if I come over here and I block this, and I run this, that is the only other way to get there. So I'll just push this cube over there real quick. These cubes are hard to push. Okay, let's make sure that it's past the node itself. That should be good. So now you can see if I come over here and press E, there's red text in the top left corner that says no path exists, and that just indicates that there is no way to get to the end. If I shoot this, move it a little. There we go. Now there is a valid path. Oh man, everything works great. Oh man, that one worked weird. Okay, that's pretty much it.